In this presentation, we are going to see about multiplexers. So multiplexers have multiple inputs, and their multiple inputs are converged into a single output, right? So multiplexers are nothing but combination logic circuits. So they have this 2 power n input lines to handle 2 power n bits, and they have n number of selection lines, right? So if a multiplexer has 2 power 3 input lines, it will have 3 selection lines, right? In the case of we'll take a case of 4 cross 1 multiplexer, right? We'll draw a small multiplexer block diagram like this. It is a 4 cross 1 multiplexer, and this 4 cross 1 multiplexer has 4 inputs, 1 2 3 and 4 input lines, right, and one single output line like this, right? So single output line. Here you can see 4 inputs and one output, so you call it 4 cross 1 multiplexer. And since you call it 4 input lines, it can be represented as 2 power 2, right? So which is equal to 2 power n. So I told you it has n number of selection lines. Now it will be having 2 selection lines, right, because 2 power 2, right, where n is equal to 2, right? The selection lines can be S0 and they can be S1, right? Now you can mention the output as X. We will discuss about the 4 cross 1 multiplexers in detail, right? So we can draw the block diagram of this 4 cross 1 multiplexer. We can design the truth table, right? And the block diagram goes like this. So we can draw an expanded version of the 4 cross 1 multiplexer like this. After drawing the block diagram, we'll be dealing with the truth table, then the equation, and then the logic circuit of the 4 cross 1 multiplexer. Now can complete the square, the block square, and can add the inputs here. This is input 1, this is input 2, this is input 3 and input 4, and 4 inputs and one single output, right? So call it 4 cross 1 multiplexer, right? So in this 4 cross 1 multiplexer, this is the input side and this is the output side, one single output side, right? So we have, I'll just change the color for the select signals, and we have 4 inputs, so 2 power 2, right? 2 power 2, 2 square. So this 2 stands for number of selection lines. So 2 power n input lines and n selection lines. So we have 2 selection lines, S0, and next one is S1, right? And let the output be X. This X depends on the number of selection lines and how you excite the selection lines, right, and not on the inputs, right? So we'll deal with the truth table now with of this 4 cross 1 multiplexer. So the truth table, so when you write the truth table, please give priority to the select signals. So we'll write the S0 first, S0 and S1, right? So draw the line, draw a table like this. I0 is the first input line, I1, I2, I'm sorry, it's I2, it's I2, and last one is nothing but the output called X, right? So you can draw a table like this. And for divide I3 and X also, last one, just a minute. Right, since there are two variables S0 and S1, initially both of them are 0, right? So what happens if both of them are 0? So this is nothing but the input line I0, right? The select signals are nothing but 0, 0 as mentioned in the truth table. Now if there are 0 and 0, so what happens, see, there will be a combination logic circuit inside the multiplexer, that will be connecting the input I naught, right? Because 0 0 is selected, input I naught will be connected to the output X, right? So input I naught will be enabled, rest of the others will be disabled, and the output I naught will be displayed on the output, right? So the next combination is 0 1. Unless there is this uh, S1 and the input combination is now S1 is now enabled, it is now 1, right? So this combination logic circuit which is present inside the multiplexer will be connecting the I1 to X. So I1 will be displayed in the output. So I0 is now 0, I1 is 1, I2 0, I3 0. So I1 is displayed on the output. Next combination is 1 0, right? So 1 0, I'll just write it as erase the select signals and make it as 1 0, right? Now what happens if it is 1 0? This combination logic circuit setup will be connecting the line I2 with the output X. Now I2 will be displayed on X, right? So I2 is displayed here. So 0 0 1 0. The next combination is nothing but 1 1, the final combination. So 0 will be erased and there is 1. So if it is 1, now I3 is connected with the combination logic circuit inside the multiplexer that will be connecting with the output. So it is I3. If it is I3, all the others are zeros and I3 is enabled and it is 1, right? So this is the truth table for a 4 cross 1 multiplexer. Just write it here. A 4 cross 1 multiplexer or mux, right? In the exams you should write it as multiplexer, right? So the output depends on how you are exciting the select signals, right? Using the truth table, we will write the equation, derive the equation for this 4 cross 1 multiplexer, right? The equation of a 4 cross 1 multiplexer. The equation, what is the equation? The equation is the output equation. Output is X, which is equal to I naught, right? When do you get I naught? You get I naught when both the select lines are at 0, low, right? So S naught, S1, since both of them are low, can put S naught bar or S1 bar. And the second is I1. So when do you get I1? When S naught is low and S1 is high. S naught is low, S naught bar, S1 is high, right? Plus I3. So I mean I2. So when do you get I2? You get I2 when S0 is high and S1 is low. S0 is high and S1 is low. So S0 is high, S1 is low. Plus I3 when S0 and S1 both of them are high, you will get the output I3, right? So this is the equation for the output equation of a 4 cross 1 multiplexer. Using this equation, we are going to derive, we are going to draw the logical circuit of this, the logic circuit of this 4 cross 1 multiplexer. So it goes like this. Uh, just from this equation, you can see we have, we need AND gates. So I naught dot S naught, right? So everything needs an AND gate here, an AND gate, and we need AND gate. So we need 4 AND gates. So how many AND gates we need? We need 4 AND gates and we need 3 OR gates, or we need a single OR gate that can connect all the 4 AND gates. Single OR gate is enough, not 3 OR gates, right? Single OR gate. So we can construct a logic circuit for this given equation, which we derived from the truth table using I naught, I1, I2 and I3. So for I naught, you can draw a straight line like this, and you can draw this. If you can follow me using a pen and paper or scribbling pad, that will be very easy for you to remember. So this is I2, the last one being I3, right? So all the inputs I1 to I3 will be connected to the respective AND gates. So this is the AND gate number 1. So this is AND gate number 2, and the next AND gate 3, and AND gate 4 will be followed. Right. So this is the time to draw the select lines. So this is AND gate number 1, 2, 3, 4, and inputs are connected directly to this, and this is the select lines S0 and S1, right? So S0 and S1, they exist as S0 and S0 bar, and S1 exists as X1 and S1 bar. So for this complement, you need a OR gate, right? A NOT gate, right? So if you give S0 here, it will be getting S0 bar outside, and if you give S1 to this NOT gate, it will give you S0 bar. So you need a NOT gate here, right? An inverter here, right? Same for the S1. You need an inverter, right? So this is fine. So now we'll see how to connect for the AND gate 1. So AND gate 1 is already connected to I0. It should be connected to S1 bar and S0 bar, right? So now we have to connect the S1 S0 bar. So S0 is connected to a NOT gate that is converted into S0 bar, and that S0 bar is now being connecting to AND gate number 1. So draw a line like this. So this is completed, and now it is time to connect S1 bar to the AND gate number 1. Can draw a line like this. Use jumpers, please. So don't short circuit with I3 or I2 or I1. Please use jumpers so that you can understand which line is going which where. So this is connected with I0. I mean I0. No, I'm sorry, not I0. The AND gate number 1. Right. So this is the output I0. So if we give 0, 0 here, both zeros will be complemented to 1, right? The two ones will be propagating to I0, right? So how this AND gate will function? It will be functioning as I0 dot 1 dot 1. So simply the output is going to be I0. So this is what happening inside the 4x1 multiplexer. Previously I was telling you that there's a combination logic circuit working inside the 4x1 multiplexer, right? This is what happening inside this, right? Similarly, we have to draw the rest of the equation. We have to convert the rest of the equation into the logic circuit. As far as the first one is concerned, it is over. The second one is I1 is already connected with the AND gate. So S0 bar should be connected with this AND gate, and S1 should be connected. So S1, see, S1 is obtained like this. If you take it after the NOT gate, it will be S1 bar. If you take it before the OR gate, it will be S1 itself, right? So we can connect. If you need S1, we can take an output like this, and that can be connected to the AND gate number 2. Directly connect this with AND gate number 2. Now, if you give, what is the second combination? You have 0, 1. So if you give 0 from S0, that will be converted into 1, and that 1 will be propagating to the AND gate number 2, right? And if you give 1 to S1, that 1 will be connected to AND gate number 2, right? It will be I1 dot 1 dot 1. So your answer is I0, right? Answer is answer is I1, right? So that is how the circuit performs, right? So I1, right? Similarly, we can go with the second one, third one. So third AND gate. So third AND gate is already connected to I2, and now you have to connect this with S0. So if you want to take S0, you have to connect the lead which is just before the OR gate. So can make it in a different color so you people can understand. I'll just make it in the red color. You see, if you want S0, you have to connect take an output just before the OR gate, right? If you take after the OR gate, it will be S0 bar. So we can connect this with the AND gate number 3. This is for S1, and for as far as S1 bar, we can there is a lead actually already there. You can connect that with the gate number 3, right? The gate number 3 will be activated with 1 0. If you give 1, that 1 is directly connected with 3, right? And if you give 0, that 0 will be complemented, and for if you give 0 for S1, that will be complemented, that will be given to the gate 3, right? So this is over, and the next one is I3, the last OR gate number 4, right? So both of them are available for you, right? I3 is already connected, and all you have to do is to take a lead from S0. Just put it in a different color girls, so you can see. So this is S0, and the last one is nothing but S1. S1 is available for you. So S1. So you can connect that with the OR gate number 4 and gate number 4. The output of this AND gate is I3, right? I3, because I3 dot S0 S1. So both of them are 1. So 1 1, right? So if both of them are 1, then the output will be I3, right? So if you want to use this AND gate, so this can invert zeros into ones and ones into zeros. So if you take an tap terminal from here, it will be 1. If you take a terminal from here, it will be 0, right? So that is what we are doing here, right, in the case of select signals. So if you take the lead from here, if you give S0, it will be give you S0 bar, and if you take an output from here, it will be S0 bar, right? If you take an input from here, output from here, it will be the same S0. So that is what we have done already in the case of select signals. So you should understand this, right, in order to understand the circuit itself, right? So the circuit is designed so that when the select signal combination is given, right, a particular set of uh, AND gates will be disabled, and only one AND gate will be enabled to give the output. Rest of the other AND gates will be 0, right? So if the input 1 0 is given, the third AND gate will be excited. The rest of the other AND gates will be disabled, right? So this is how the 4x1 multiplexer is behaving, and um, all the other input leads can be connected to the OR gate, right? So that you can get the value X. So I0, I1, I2, and the last I3 can be connected to this OR gate. So the output is X, right? So the X connects all the inputs. To put this as a very simple, in simple meaning, right, we can use the example of 2 cross 1 mux. 2 cross 1 mux has 2 inputs and 1 output. This is I0. The I0 can be connected with an OR gate, sorry, an AND gate. This is also connected with an AND gate, right? So the select signal, only one select signal will be available for you because you have only 2 power 1. That select signal should be having an inverter, a NOT gate, right? So this lead of this NOT gate is connected with the output of this NOT gate is connected with the AND gate number 1, right? So the other end is connected with the AND gate number 2, right? So this is an AND gate, and this is also an AND gate. Both the AND gates are connected with the OR gate. Right, if you give 0 to this, right, this 0 will be propagating to this wire, and it will be reaching the OR gate number so 2, and there will not be any output. This 0 will be complemented as 1, and that one will be propagating to this and gate number 1, right? Then the operation that is happening inside is nothing but I0 dot 1. So you will get I0 in the output, right? Instead, if you give 1 in the select signal, that 1 will be propagating to this AND gate number 2, right? Now this AND gate will be having a value called I1. Instead of nothing, it will be giving you I1 to the output terminal X, right? This 1 will be complemented as 0. That 0 will be propagated to the low voltage will be given to the AND gate number 1. Then the AND gate number 1 is not going to give you any output, right? So this is how the select signals are excited to excite a particular and get only. If you give s equal to 0, I naught will be excited at the output, and if you give x equal to 1, right, if you set high at the select signal 1, and the x will be having the output I1, right. So we'll now draw the symbol for this multiplexers, right. Symbol of multiplexer. So the symbol for multiplexer looks like a compressor, which we usually study in terms of mechanical engineering. It looks like a compressor because the inputs converge at a single output. This is I naught and this is I1, and this is the output called X, right? And the last one is nothing but the select signal. Without select signal, the multiplexer cannot function, right? So this is a symbol of a multiplexer because it looks like a compressor because the inputs are compressed or they converge at a one single point. That is why it is mentioned as this. So thanks for watching.